So this section contains two matrix match the column type questions. Entries in column 1 may have one or more than one entries match against them in column 2. So let us start with question number 36. Column 1 contains reactions and column 2 contains properties or major product of the reaction given in column 1. Match column 1 with column 2. So students, in the A option, we have been given a structure and it is allowed to undergo oxymercuration demercuration. So oxymercuration demercuration leads to the formation of an Markovnikov alcohol without the rearrangement. So if we talk about the product which is formed in this case, we are going to have the formation of this structure. Let us look at the reaction given in B now. We can probably figure out the matchings later. So in the structure given in B, it is allowed to undergo hydroboration oxidation reaction. So in this case, the anti-Markovnikov product is formed without rearrangement. So the addition of OH will take place at the terminal carbon. So which will lead to the formation of this alcohol. Let us look at the reaction given in option C. So this structure is made to undergo hydrolysis in presence of H plus H2. So here there will be the formation of a carbocation. So in this case, we'll first have the formation of this structure and then this carbocation will rearrange to give us a more stable tertiary carbocation. And on that carbocation, the addition of OH group is going to take place. So the alcohol formed in the C reaction is this. Let us look at the reaction given in statement D now. So we have this cyclic structure which is allowed to undergo hydroboration deboration, and we had seen that hydroboration deboration leads to the formation of anti-Markovnikov product without rearrangement. So the product formed in reaction D is going to be this. So let us look at the matchings now. So the product formed in A, it is a secondary alcohol. It will be matched with Q, and the formation of this product involves the rearrangement of carbocation or cyclic transition state as mentioned in the option T. So this is going to be matched with Q and T. Let us look at the second reaction now. So the product formed is a primary alcohol in this case. So P will be matched with this. It is a syn addition only. The product is formed by syn addition of H and OH. So this is also going to be matched with S, and T will be matched with every single one of these products formed. If you look at the product formed in C now, it is a tertiary alcohol. So it will be matched with R. It will not be matched with S because there is a formation of carbocation, and the attack on the carbocation can happen from both the orientations. It can happen from above the plane or it can happen from below the plane as well. So S will not be a match. It will be matched with T. There is a rearrangement of carbocation in this case. Let us look at the last option now. We have a secondary alcohol with us. So it is matched with Q, and it is the product of syn addition only, and the reaction also involves a cyclic transition state in this case. So students, this is the correct match for this question. A will be matched with QT, B will be matched with PST, C will be matched with RT, and D will be matched with QST. Let us look at the next question. Let us look at question number 37 now. Column 1 contains different compounds while column 2 contains different characteristics of the compounds given in column 1. So if we talk about the first compound which is given in column 1, we have Al2CH3 6. So if we try and draw the structure of this compound, so we have aluminium, we have CH3. So there are two different type of CH3s. One are the terminal ones and the other is the non-terminal ones. The non-terminal CH3, they form banana bonds with aluminium. So these are electron deficient 3-center 2-electron bonds, as in the case of diborane. Both these bonds indicated are banana bonds. These are 3-center 2-electron bonds. So these are normal 2-center 2-electron bonds, the normal covalent bonds. The hybridization of aluminium is sp3, and the molecule will not be planar. So if you look at the options which are matching to option A, we have 3-center 2-electron bonds, so P will be a match, Q will not be a match, R will be a match as there are 2-center 2-electron bonds. So PR, the molecule is non-planar, S, and hybridization is T. So PRST will be a correct match of this compound given in option A. Let us look at the next compound now. We have Al2Cl6. We can draw the structure of Al2Cl6 as well. So we have AlCl again, similarly, there will be two type of chlorine atoms. One will be the terminal ones and the other will be the bridged ones. So chlorine here forms the 3 center 4 electron bonds, as chlorine has lone pair of electrons. So the indicated bonds, these are 3 center 4 electron bonds. The terminal ones are normal 2 center 2 electron bonds, like the normal covalent bonds. And the hybridization of aluminum is again sp3. The molecule is non-planar. So if we talk about the matching of compound given in option B, we have 3 center 4 electron bond, which is Q. We have non-planarity, which is S. We have 2 center 2 electron bond, which is R. And we have sp3 hybridization, which is T. So B will be matched with QRST. If we talk about the third compound now, which is dimeric BeCl2, we can draw the structure of dimeric BeCl2 as well. So BeClCl, and we can have one another unit, BeClCl. So the chlorine forms the bridge to form the dimer in this case. So again, these bonds like Al2Cl6, these are 3 center 4 electron bonds. The terminal bonds are normal 2 center 2 electron bonds. The hybridization of beryllium is sp2, but the hybridization of chlorine in this case is sp3. So chlorine atom is sp3 hybridized in this case. So if you look at the matchings of option C, we have 3 centered 4 electron bonds present, which is Q. We have 2 centered 2 electron bonds, which is R. We have a planar structure, so S will not be a match. And we have the sp3 hybridized chlorine atoms in this case. So T will be a match. If we talk about the last structure, which is B2H6, the structure of B2H6 is known to us all. It is diborane. It has a banana bonding. So these bonds are banana bonds, which are 3 center 2 electron bonds, whereas the normal terminal BH bonds are 2 center 2 electron, and the hybridization of boron is sp3 in this case. So if we talk about the matchings of compound given in option D, we have 3 center 2 electron bonds, P. We don't have Q, we'll have R, we'll have non-planarity around the boron atom, so S, and we have sp3 hybridized boron atom as well. So T will also be a match of option D. So students, this is the correct match for question number 37. Let us look at the next section,